Okay, here's a little bit more about functions. One of the main points of this discussion here is to introduce the idea of extensionality or equality for functions. But we're also going to be a little bit more careful about what we mean by when we're talking about partial and total functions. So, um, for example, we know what a function is. It's a subset of A cross B that's functional. And those two conditions give you the partial functions. And they typically write partial functions like this, as opposed to the full arrow for total functions. There's other ways mathematicians write them. They sometimes write them like, I don't know, I think something like this to mean partial function, or like this to mean partial function. But the one I see most in computer science is that to mean partial function. Um, so those are the partial functions from set A to set B. Now, we can describe that thing is itself a set. What is it a set? It's a set of all f's. What are f's? F's are subsets of the Cartesian product where f is functional. So that's the set of all partial functions are subsets of the Cartesian product where the relation f is functional. Now, if we're talking about total functions, then we use this. And so then we do the same kind of thing. We can define the set A arrow B to be the set of all f, such that f comes from A cross B, f is functional, and f is total. So if you just, when you're looking at the notes, I'm going to upload these notes as a PDF. Remember, it's functional if no x can't go two different places. If x goes to y and x goes to z, then y must be equal to z. And it's total, a function is total, if everything from A goes somewhere in B. There's no leftover edges. Just a little aside here about counting these things that you probably had in 2030 is that the cardinality, and we put these vertical bars to sort of indicate the size of the set of partial functions from A to B is the size of B plus 1 raised to the power of A. This is really, I should have written this like this. This is let me write it again out here. The size of B plus 1 raised to the power of the size of A. A lot of times, I was just going to say that, sometimes we write A arrow B, and mathematicians might sometimes write, or category theorists might write B to the A to denote all the functions from A to B. But I guess that's just another bit of notation. So what about how many total functions are there? Well, there are B to the A total functions. And remember, for the Cartesian product, the size of the Cartesian product, A cross B, is the size of A times the size of B. So, since the size, for example, you can think about the size of the Booleans. There are two Booleans. So that means there are 16 total functions of type B cross B arrow B. And you might try to work out that using these three equations up above. Okay, so now we come to this very important topic, is equality of functions. Oh, that's really ugly. Okay. what does it mean for two functions to be equal? So if f is a function from a to b and g is a function from a to b, then f is equal to g by definition if every input x, every element of the set A gets mapped to the same value by f and g.